This image from the radar instrument aboard NASA's Cassini spacecraft shows the large hydrocarbon sea Ligeia Mare on Saturn's biggest moon, Titan. Credit NASA's Ligeia Mare on Friday, September 15. NASA's Cassini mission will come to a dramatic end, burning up like a meteor high in Saturn's atmosphere and concluding the spacecraft's daring grand finale. This final goodbye was made possible a few days earlier on September 11, when the veteran spacecraft was given a gravitational nudge by Saturn's largest moon, Titan, during the probe's final flyby. Cassini has been in a long-term relationship with Titan, with a new rendezvous nearly every month for more than a decade, Cassini project manager Earl Mays at NASA's Jet Propulsion Laboratory in Pasadena, California, said in a statement. This final encounter is something of a bittersweet goodbye, but as it has done throughout the mission, Titan's gravity is once again sending Cassini where we need it to go. Since arriving in the Saturnian system 13 years ago, Cassini has had an intimate relationship with Titan, studying its atmosphere and using the 3,200-mile-wide 5,150 km moon's gravity to fine-tune its orbits. But this intimacy peaked on January 14, 2005, when the European Space Agency's robotic lander Huygens descended through the moon's atmospheric haze and landed to become the first and, so far, only mission to touch down on a moon surface in the outer solar system. 12 years later, scientists remember epic landing on Saturn moon Titan on October 15, 1997. The $3.2 billion Cassini-Huygens mission was launched from Cape Canaveral, Florida, as a joint endeavor among NASA, ESA and the Italian Space Agency. The mission began with two conjoined spacecraft, an orbiter and a lander, but on December 24, 2004, Huygens detached from its mothership, leaving Cassini to orbit Saturn alone. Huygens had its own destiny to land on Titan and reveal the ground truth beneath its haze. The Huygens descent and landing represented a major breakthrough in our exploration of Titan as well as the first soft landing on an outer planet, a moon, Cassini project scientist Linda Spilker, of NASA JPL, said in a statement earlier this year. It completely changed our understanding of this haze-covered ocean world. Titan is an oddity. No other moon in the solar system possesses a thick atmosphere, and planetary scientists are deeply fascinated with this mysterious world. 3 weeks after leaving Cassini and coasting to Titan, the 9-foot-wide 2.7 meters spacecraft parachuted through Titan's opaque, nitrogen-rich atmosphere, spinning and wobbling as it captured imagery and gathered that of the moon's trademark yellow haze for nearly 2.5 hours, revealing intricate details of the atmosphere's layers, winds, composition and mysterious chemical processes. But Huygens was descending into the unknown. At the time, planetary scientists weren't sure if Titan's surface was covered in a liquid soup of methane and ethane, so Huygens was designed to float in case it didn't find solid ground. But as the lander continued to sail deeper into the eerie depths, eventually passing under the haze, it captured hundreds of aerial images of the alien world and saw a surprisingly diverse, and strikingly Earth-like, landscape filled with mountains, dry floodplains and what appeared to be river deltas. Scientists then realized that though Huygens had landed on something solid, liquid methane did flow there. Huygens cameras could see intricate channels cutting into the surface. When Huygens touched down, it did so with a soft thud and a short slide across the frozen surface. Later analysis of the lander's telemetry showed that Huygens sank around 4.7 inches 12 centimeters into the surface on first contact, bounced and slid before coming to a stop. Reflecting on the landing in 2012, Eric Karkoshka, of the University of Arizona's Lunar and Planetary Laboratory, likened the strange surface to snow with a frozen crust. If you walk carefully, you can walk as on a solid surface, but if you step on the snow a little too hard, you break in very deeply, he said. Huygens had landed on a dry floodplain littered with eroded, icy rocks covered in a dusty material that was likely organic aerosols that are now known to form in Titan's atmosphere and precipitate onto the surface. For 72 minutes, the lander returned valuable data from the moon's surface and atmosphere. When Huygens' batteries drained, it stopped transmitting, but that was only the beginning of Cassini's explorations of Titan. For another 12 years, the mothership carried out 127 close flybys, gaining new observations on each orbit around Saturn and cutting through the haze using its radar. How humans could live on Saturn's moon Titan infographic. By comparing the observations by Cassini and Huygens, researchers soon found that liquid methane does flow on Titan's surface, and there are vast lakes of liquid methane and ethane. These lakes are the end product of a hydrological-like cycle on Earth. Water evaporates from the oceans, condenses in the atmosphere and falls as rain over the land to create rivers. On Titan, methane takes water's place. As Titan receives only 1% of the sunlight Earth receives, it is extremely cold. The average surface temperature of Titan is -290 degrees Fahrenheit, -179 degrees Celsius, so water cannot exist as a liquid. It is only found as rock-hard ice. But methane, which is found naturally only as a gas on Earth, is the dominant liquid on Titan, creating lakes, condensing as aerosolized methane clouds, and falling as methane rain on the hydrocarbon-rich landscape. Despite the extreme temperatures, astrobiologists view Titan as an analog of a young Earth from around the time when organic chemistry led to the emergence of life billions of years ago, and some hypotheses suggest that exotic forms of life may be possible on Titan. But the possibilities of Titan's habitability go much deeper. From Cassini's many flybys, scientists have learned that Titan likely hides a vast subsurface salty ocean below its hydrocarbon-rich surface. This means Titan joins the growing club of ocean moons in the outer solar system, including its Saturnian sibling Enceladus and distant Jovian cousin Europa. Cassini's up-close exploration of Titan is now behind us, Spelker said in a statement after the spacecraft's final close flyby of the Moon in April, but the rich volume of data the spacecraft has collected will fuel scientific study for decades to come. Now, Cassini is on an irreversible course to enter Saturn's atmosphere at 7:53 a.m. EDT 11:53 GMT on Friday and complete its incredible mission, burning up and protecting Enceladus and Titan from possible contamination. Follow Ian O'Neill on Twitter at AstroEngine and at astroengine.com. Follow us at space.com, Facebook and Google. Original article on space.com.